Okay, before we begin in this section, we actually need to go over our laws of exponents, our rules of exponents, so that we can remember how all of these things work together, and we can use these rules then as we go. Okay, so for our laws of exponents, we need to remember, first of all, the zero exponent rule, meaning anything raised to the zero power is 1, no matter what, as long as the base is not 0, because we don't have 0 to the 0. That's not defined. But any number to the 0 power is 1. Then we have our negative exponent rule that says if you've got a negative exponent, that's really the reciprocal. Okay, don't forget that. Then we have our product rule that says whenever you're multiplying two bases that are the same, we add the exponents. So that's what that rule is saying. Then we have our quotient rule that says when you're dividing two bases that are the same, we subtract the exponent. So this would be r minus s as our exponent. We have our power rule that says anytime you're raising an exponent to an exponent, you actually multiply those two exponents. So this would be r times s. We have a product to a power rule that says anytime you've got two things multiplied, or it could be more than that actually, but a product, things being multiplied, raised to a power, it's almost as if you are distributing that power to each one of those items in the parenthesis. But this only works with multiplication. It will not work with anything else. Okay? Our quotient to a power rule says anytime that you're dividing things and raising to a power, again, it is as if we are distributing that power to both the numerator and the denominator. And then we have our quotient to a negative power rule that says anytime you've got a quotient that's raised to a negative power, we could look at this two different ways. We could either say, well, this negative exponent means that these are in the wrong position, so we could flip them over, raised to that power. Or another way even of looking at that is using the rule before it. If we said that each one of those gets that power in that quotient, that would be a to the negative r over b to the negative r, and then we could simplify each one of those. Because this is a negative exponent, it belongs in the denominator. So we can correct that negative exponent by placing it down on bottom. And the b to the negative r, again, this says that it's in the wrong position, so we could correct it by placing it in the numerator. So this would be b to the r on top. So this is the exact same thing as this answer here also. They could be written either way. Okay, as we get into these problems, they're just simply going, that's all they're going to say for directions. It's just going to say simplify. Now, whenever we're simplifying, the rules are all of your exponents have to be positive. Each base has to occur only once. So if you had a 5 on top squared and then a 5 on bottom, we can simplify that because those bases appear more than once. So there's more we could do to it. There are no parentheses in the expression. We've cleaned up as much as we can. And there are no powers written to powers, because power to power you multiply. There's a rule that we can continue on with this. Okay, so if you need to, then you might want to stop the video and write down your rules and make sure that you remember all these exponent rules before we actually get into working problems. This will help you tremendously if you have these rules down pat before you begin.